Go ahead and record. What's a rational, what does it mean to be a rational number or a rational expression? What's rational make you think when you say rational?
Real number.
It starts with an F, but it's not an ugly word. No, fraction. Fraction. Think about, I did not know, as soon as it came out of my mouth, it's an F word, but before you blurted it out, I wanted to clarify. Not an ugly F word. Okay, although fraction is ugly to some of you. All right, so we're going to look at things that are very involved in the top and the bottom of the fraction. But before I do, I want to go over a couple concepts that you should know, but maybe you've forgotten. If I have something like 2x squared over 6x, okay, and I'm simplifying that down. If I write this in factored form, 2 times x over, what's the factored form of 6? 2 times 3. Meaning like prime factorization, factor it down as much as you can. What?
Yeah.
What was 25 on the test?
Oh, wait, what was the answer? I got the first one.
Yes, that's a times in between. So we talked about properties of exponents. Let us subtract these exponents, right? 2 minus 1 is 1. But then another way to think about it, if you're multiplying in the top and the bottom, you can cancel things out, right? If it's in both places. So that's the whole concept behind simplifying rational expressions that we're going to talk about today. So it's x over 3, which you could have gotten by saying, well, 2 over 6 is 1 over 3, and 2 minus 1 on the x's would leave you 1. Okay? It's just another way to think about it. It's going to help you with the rational expressions. So, not a lot. Okay. You good? All right, let me show you an example of a rational expression. Now, Sarah pointed out, that's why you have that poster back there. The way it sits right now, I cannot do this. Okay? Because they're not being multiplied or divided. I mean, they're not being multiplied. Over the file cabinet back there. Every time you do this, a kitten dies. You can't cancel that term out that way. Because it's not x squared times 2x. If these were multiplication signs instead, you could. All right? The key is you can only be multiplying when you start canceling things out. So what I have to do to simplify, my key to this, what did I tell you before we started, the key to this was? Factoring, same thing. Factoring, all right? So I'm going to factor everything. That's going to be your first step before you do anything with rational expressions. So looking at this fraction, look at the top. Can that be factored? Yes. And I hope that you don't have to group this to factor 1 with a leading coefficient of 1. But if you do, it's okay. What multiplies to negative 15 but adds to negative 2? Negative 5 and 3. So it's x minus 5 and x plus 3. Negative 5 and positive 3. Do you need me to group it off to the side and show you?
I mean, I've never done that. Like, just skip all that.
Well, because the thing is, when the first, this only works when that leading coefficient is 1. If there's a number in there, it doesn't work like this. But anytime that's the case, when you set it up, minus 5x plus 3x, it's always going to, these two factors are always going to be what these two numbers are. So it's x times x minus 5, 3 times x minus 5, which is x plus 3, x minus 5. Okay? How about the bottom there? Yes, good job, Donovan. Difference of two squares. Somebody, I think Isis, were you saying what it was? Yes. X minus 3, x plus 3. Now take a look at it. All of my addition and subtraction signs are contained within parentheses, which means they're contained within factors, okay? So they're multiplied. That's exactly right. So this is like, it's not like it is. This is x minus 5 times x plus 3. This is x minus 3 times x plus 3. So now what I can do is I can simplify by canceling out factors in the top and the bottom. So what cancels? Bless you. X plus 3. Leaves me with x minus 5 over x minus 3. Can I cancel the x's out? No, why? You'll kill a kitten. Nothing, I'm just kidding. It's not being multiplied, right? The factor here is x minus 5 and the factor is x minus 3. This one's for you, Evan. Simplify. Hello. These are easy because there's no leading coefficients. So, Evan, does it factor?
Yeah.
How does it factor? You sure? 4 and 4. It's a perfect square trinomial. Avery's favorite. Square dances. What we use to complete the square. X minus 4, which is x minus 4 squared. Multiplies to positive 16 and adds to negative 8. Okay. That's okay, but you would have come back to the same answer, so it's okay. How about the bottom? Multiplies to negative 24, but adds to positive 2. 6 and negative 4. Positive 6. And understand these are just this easy to factor because the leading coefficient is 1. Okay, be careful. Yeah, we will, but I just... Yes. Yeah. What? You sure?
Don't say that.
I'm just kidding. One more. Una más.
3 minus. Yeah, I thought there was an x plus 4. No.
It's got to add to positive 2, but multiply to negative 24. Positive 6 and negative 4.
Okay.
Are we getting stumped up on the factoring? All right, one more. Try this one on your own and see what happens. Don't quit.
You got it 2 times x times x.
What did you just say?
Spread out the 2x squared.
Spread out the 2x squared. You're actually really close. You're really, yeah.
So you take the 2, so you get 2
GCF on the top. Remember, the first step of factoring is GCF if it has one.
I don't know what I saw on the first slide.
You just take out the 2x, and it leaves you with x plus 5. No, Evan said right. 2 times x plus 10 times x.
That's what you did on the first side. It was like 2x.
There was no addition subtraction on that one. Can you do what? I can't do that? All right, let's look at the bottom together. This is not as easy a factor because there's a leading coefficient. So what two things multiply to 15 but add to 16? 15 and 1. 3x, x plus 5, 1, x plus 5. So I have x plus 5. What? She just got tickled, and then was like, I can't factor. All right, take a look here. The x plus 5s go away, and I have 2x over 3x plus 1. All right, sidebar. Let's factor. Woo! Yes. Oh, well. Stick a fork in you. He said, if that's not as hard as it gets, I'm done. We're literally on the introduction of the lesson. All right. Thank you, timekeeper. We appreciate that. Factoring.
But like this doesn't amount to having to teach ourselves algebra 1 and like we had like the examples in class when
Factoring. Here we go. This is good final exam review stuff anyway. Y'all, please do not get to Miss Twitty's class next year and tell her you don't know how to factor. Oh my God. Do not say that I did not teach y'all that. Don't say, are you sure we learned that?
10 and 3.
Okay. Look. Multiply the first and the last term together. Negative 30. So what two things multiply to negative 30 but add to positive 13? Woo! What? 15 and negative 2. The only way to get a negative number when you multiply is if one is positive and one is negative. One has to be positive, one is... Because they wouldn't have multiplied to negative 30. You could have gotten them to multiply, but you couldn't get them to add to positive 13. Well, if I did 10 and negative 3, that adds to 7. And negative 10 and positive 3 adds to negative 7. So they wouldn't add up to the middle.
But she's saying if this was a positive 10, it would work.
Yes, if that was a plus 10 on the end, 10 and 3 would be your two factors. All right. These are what we use to rewrite the middle of the equation. 3x squared. I always start with the minus term. It makes factoring a little bit easier. Plus 15x minus 10. If you look, what is negative 2x plus 15x? I've just written it a different way. And now I'm going to group it. GCF of the first two terms? What's the left? Bring down the first sign. GCF of the second two. What's left? I didn't see the one in front of it. All right, so now the 3x minus 2 goes in the front, and I have x plus 5 left, and it's factored. Nope, doesn't matter. All right, you have to be able to do this entire chapter.
Okay.
Well, now it makes sense.
Okay. A little refresher.
There's gonna be
Avery.
fractions in this, aren't there?
Mississippi, I swear I don't remember. I just remember
Oh.
factoring out the 3 and then putting everything else in and factoring
Dude,
out.
factoring the only thing I know in algebra too.
Okay.
It's like, that's my heart and soul.
Evan, please don't tell people that.
I mean, I'm proud of
I've
you.
been teaching you for a whole semester. And the only thing you know is how to factor.
No, well, give me a
I mean,
test.
no, it's his
I'll
fault.
mess
You
with
see
you.
them say no.
But like, I can't remember.
So, simplifying is easy. And we're going to use that as we multiply. From here on out, everything we do with rational expressions, in the end, Justin, what are you doing? At the end of, say, multiply these rational expressions, your directions will be, and then simplify. Divide these rational expressions, and then simplify. Add the following, and then simplify. So you have to have simplify, that's why I showed it to you first, okay?
Thank you.
Multiplying rational expressions is simply multiplying fractions because rational expressions are fractions, okay? So, let's look at one. This is a fun one. That's exactly right. That is exactly right. In fact, I'm going to write that, Olivia. Straight across. When there's an equal sign in the middle.
I learned that in 7th grade and haven't used it since. So,
All right. Big multiply problem here. If you look at this as two separate rational expressions and you factor them down before you start, it will make your life a lot easier. Okay? So in other words, what I'm going to do, maybe I should write that. Factor first. Look at the top of the first fraction. Can it be factored? Factor out of 3x. What's left if you factor out of 3x? Yes. Oh. There's no leading coefficient, so this should be an easy factor.
you can't multiply 5.
How'd you get the green from x minus
All right,
1x?
hold on. I took a 3x out of here.
It's factoring.
I'm factoring everything. I'm just going through and factoring the top and the bottom of each fraction. Okay. So green goes with green. I'll color code it for you. Pink. Okay. How do you factor x squared plus 4x minus 5? Yes. Because it's what multiplies to negative 5 but adds to positive 4. X minus 1.
We're talking important.
Yeah. Right?
Yes, ma'am.
Out of what? We're gonna wait till we put everything together to start crossing out. All right. Second fraction up top. Can that be factored? What multiplies? There's no leading coefficient. 5 and negative 4. Then obviously the 3x is there. It's 3 times x or 3x. Now, see, you're jumping ahead. Look at you. You know how to multiply rational expressions. Well, we can start, the reason we can start, golly, y'all are killing me. This is like one big fraction, because when you multiply straight across, right? And since everything's factored down, I can multiply just this way. So now, yes, Cullen, we can look at what looks the same and we can start canceling.
3x, cancel 1 minus x, cancel x.
Ah, not the 1 minus x.
Well,
But
oh
we're
wait,
going
it's backwards.
x plus 5.
So it's x minus 4 of, wait, no.
1 minus x times x minus 4.
Now, I'm glad a lot of you are looking at that 1 minus x and x minus 1 going, golly, those are really close, and they are. What could you factor out? And you're going to have to think about this.
Oh. So that's not the final answer?
-1.
Yes. Good job.
Wait,
If I factor out a -1 from 1 minus x, it changes it to -1 plus x. And is -1 plus x the same thing as x minus 1?
Yes.
well, where do you get the -1 from?
I factored it out.
From what?
1 minus x.
From your imagination.
The same way if it was 2x plus 8, I could take a 2 out.
Because you can multiply
Yeah,
every
but
one,
if you-
negative 1 gets positive 1.
If you multiplied that back out, would it give you back what you started? Right.
But
Right.
So you take the -1 in front of the x. See, that makes no
So
sense.
then once you cancel them out, you can just reduce -1 back into the x.
I would just leave it that, or you could leave it as like this. You could do -x plus 4,
Could this be the final answer?
or you could do 4 minus x.
That's how you have to solve.
Could this be the final
Which
answer?
one?
That.
I would like to see you be
Alright,
able to pull that
that-
-1 out. I would like to see you be able to pull
But
that
you
-1
would
out.
accept you would
I
accept
would
that.
like to see you be able to pull that -1 out.
So you would,
Yes.
but you would accept this.
Either or, any of those circled would work.
Hold on.
Yes, ma'am.
I understand what you got
What you gonna do first?
for
Take 5x out of the top. Do it. Can I do it all in one color, or do I still have to color code it? One color. Okay. 5x leaves me with what's left.
4.
Welcome. 4 minus x over x minus 1 times, how about the top? Uh-huh. Oh, wait, x plus 4. X minus 1. How about the
Bottom's a different.
difference? You got it? Okay. Yes, you're right. Difference of 2 squares. I'm fixing to throw some 2 cubes up here and see what you remember.
I got one. Cancel out.
Cancel
Cancel out the 2 x.
out the x plus 4s.
X minus 1.
X minus 1. I don't think so.
Factor out a negative.
How about this x here? All right, let's see what we got. Up top, I got a 5 and a 4 minus x. And on the bottom, what do you notice?
But how does the x minus 1 cancel out? Or because it's one big fraction.
Yes, this one looks like. This is an example, and why I chose this one is because, yes, Evan, it's not fully simplified until you factor out the -1. Because, all right, remember I'm multiplying. If I take a -1 out of the top, -4 plus x, yes?
Yep.
Or maybe you factor a -1 out of the bottom, it doesn't really matter. X minus 4. The cool thing here, those cancel, right? So that big nasty expression cancels down, or reduces down to -5.
That's where I was confused.
Now let's close that
Okay,
out.
here's what I changed it
Is
for
that
by.
X, or is that just the whole thing?
That's the whole thing. We're not solving, we're just simplifying. Yes, Isis? Hold on just a second.
How much every time you bring it down, you switch the sign. Why do you write it down?
Every time I bring it down, what?
Okay, so okay.
You talking about from here to here?
Yeah.
Because I took a -1 out, because I wanted to change the signs. Because I noticed that these were the same, just with opposite signs.
Show that.
Yeah. Well, I put the -1 there, yeah.
You know, 14. I can divide that one by.
Guys. Oh, I gotcha. You got to divide both of them. Both of them. All right, let's look at division. When you see how easy this is, yes. When you, oh, wait, I got to show you one more. Just one more. Yeah. Because I can't skip this. You have one like this on your test.
Are you already over a test flag?
I always put one of these on your test.
Oh, why is there a difference in two Q's? Why are you doing this to us?
X minus 3, X plus 3.
No. Sum and difference of two cubes is completely different from difference of two squares. No.
No, it was like A squared something.
All right, I'm going to write a little pattern up here.
Why do we have this on the test?
Is it minus plus minus?
Yeah, it's same change plus. This is a difference. So a cubed minus b cubed factors as a minus b, a squared plus ab plus b squared. Same change plus. Little parenthesis, big parenthesis.
Oh, I like those.
And then it could also be a sum of two cubes.
There is no B, there is no power to B though.
Okay? So looking at this several, Justin, you need to come back up here to your seat because you have talked the whole time. Yeah. Okay. Thanks, guys, for that affirmation. That was very quick. I don't know that that's ever happened when I have moved a student before. All right. All right. X plus 2 over. Oh. I was like, I'm definitely not. I forgot I wrote something on the whiteboard. Yes, your B is 3.
What's that?
Difference of two cubes, sum of two cubes.
The sum of what?
I just take a picture of it and
If that's what floats your boat. Same change plus. We do little parenthesis, big parenthesis, same change plus.
Oh, I will.
I don't know what that means.
I will.
Guys, wouldn't the A become what? It's just a pattern. All right. Look at the bottom here. So this time my A is X and my B is 3. Little parenthesis, big parenthesis, same change plus. What multiplies by itself 3 times gives you X cubed? Yep. Multiplies 3 times gives you 27. You square the first, you put them together, and you square the last. Yes, sir. Absolutely. Yes. Absolutely. So the question was, could we put this over 1? And you can. Notice I didn't factor that. Why did I not factor that? It's a CBF. It cannot be factored for 1. And for 2, It's gonna cancel out with that. That whole trinomial is gonna cancel.
Will it cancel like that on the test?
It's always a possibility. See?
Okay, Miss Vicky, are we gonna?
All right, division. When we get to solving, we won't be solving till the end of the chapter. All right, division. Someone has already said, when you divide, you multiply by the reciprocal. So that's what we're going to do. Multiply. Can I put reciprocal up here? I couldn't put that up there last block. I had to put flip. Okay.
Oh.
They do. I've told them 1.5 million times.
But they don't listen.
It's just a fancy word for flip. Then can we just write flip? Okay, just write flip. That's fine. Just write flip. Okay.
What's the point? Just say flip. That's why the English language is so hard to learn, because it's one of
Okay, thank you, Professor Evan. Moving along, 7x over 2x minus 10 divided by x squared minus 6x over x squared. And I'm not going to do, I'll probably do one of these because really multiplication and division are the same thing. One of them you just flip over that second fraction, right? We do. So what we're going to do is we're going to rewrite it as a multiplication problem. And we're going to factor. Now, because I'm lazy, a lot of times I will come here and I will just go, oh wait, that's not 2x minus 10, that's 2 times x minus 5, because I don't want to rewrite the whole problem again. But if you want to rewrite it, go ahead. Does it factor? X minus 6, x minus 5. X times x minus 6. What can't?
The x cancels out.
All right, let me rewrite this so you can see it, because some of you are. Two x. I just like them to be in the right form. 2x, x minus 5, x minus 6. Oh my gosh, how nice is that?